All right, page 2 starts out no different from what we've been doing all along since lesson 1. They give you the ratio, and they want you to complete the ratio table. So why don't we do that first? And then I'll call somebody up at the board, and you can enter your values. All right, Moose, go for it. Shh. While he's filling out the values, let's keep it quiet because we are recording. All right, raise your hand if you have this. Okay, great. Now, here are things that I expect you at this point to know with very little bit of thinking about it. I want you to kind of get it quickly as quickly as possible. What's the value of the ratio table? That's something that I now expect you to kind of know pretty quickly. So we're going to be doing it quite a bit. Becca, how many think it's 2 to 6? Beck, is there a number that goes into both 2 and 6? What number goes into? Kathy, you almost took out Becca's eye. Beck, you didn't even notice. A pencil just went flying right by your head. How did that happen? Beck, is there a number that goes into both 2 and 6? What? Okay, so she realized 2 goes into both. The value of the ratio table is 1 to 3. Let's put that off to the far left. I would also expect you to know multiplicative structure. Going from top to bottom. Go. Times 3. Because once you have multiplicative structure in your head, you really do have an equation in your head as well. You just don't realize it, but you're going to need that times 3 when you make your equation. Only difference between the equations you've been doing and these is they're calling the variable R for red and B for blue. So red R equals what? Those of you that already did this, I'm going to show it. I'm going to write it a different way because I want you to become used to it. Amanda Johnson. R equals, this 6 equals what? You're going to need a B in there. B times what? Okay, everybody say B times 3 is going to give us R, right? Watch what I'm going to do. I'm going to show you something new for some of you. R equals 3 B. Okay, this is something new, but I've got to start exposing you to this because you're going to see it more and more. And when we get into Mod 4, you're going to see it all the time. When you see a number next to a variable, what operation should you do? Joe Domino. It means to multiply. So normally we would write this like this, or we might write it like this. You're not even going to see the dot anymore. Do you know why we get rid of the dots? Why might the dot be confusing? Because it might look like a decimal. So get used to seeing the number next to a variable. And also, just so you know, when we do it this way, we always put the number before the letter. That's just the way it's done algebraically. But it means to multiply. What did we teach you? How do we know that this equation is correct? What can we do to prove it? Lucas. You got it. It's called substitution. Give me a value that you'd like to plug in for B.
6.
Okay, so I'm going to take my 6. You can do this kind of visually, mentally also. If you wanted to do it in your head, as long as you're doing it, you don't have to show it. But I'm going to take that 6 and make believe I'm going to substitute this in for B. 3 times 6 is what? Say it out loud.
15.
It works. We know that the equation is good. Okay? I don't it doesn't matter whether you do this by writing it out or whether you do it mentally, but you should do that every time you have an equation to test to make sure it works. Okay. Get rid of those extra marks. Okay. What about for B? B equals what? Well, correct. Now, there is a way to rewrite this not using a division symbol. Is anybody curious? Does anybody want to take a shot? Maybe take a guess? But I'm not going to keep you responsible for it just yet because it's too much. There is a way to show division without showing a division symbol that we do use when we get into algebra. Aiden, do you know? What do you think? Come on up and show me what you think it is. Put it over here so it's out of the way for now. No, not that. It's a good guess. There's nothing wrong with taking a risk and trying it. L. M. Come up. Show me. So I think you might get it. R divided by 3. Yeah, she's got it. That's how you would do it. Okay? I'm not going to introduce it just yet. I introduced it, but I'm not going to use it because I don't want to give you too much at one time. But that's the way you're going to start to see it eventually down the road. However, I do want to show you this. You could, but I'm giving you something else here. I don't want it to be too much all at once. I do want to show you this though. Same thing, B equals, but what is the same thing as dividing by 3 using multiplication? Dividing by 3 is the same as multiplying by what? Yeah, maybe. Okay, what I'm asking you to do, because we were to do this back in lesson 13, but it was too much at once, but now I'm kind of giving it to you in small doses. Dividing by 3 is the same as multiplying by what value? And we're going to prove it by substitution. I'm going to show you that it will work for both division and multiplication. Pick somebody. B equals R times what? All right, Gabby, first crack. Well, call it out. Call it out. Wait, time out. It's still B equals. B equals R, not divided by 3, but times what? It's. Yes, she's got it. She's got it. She's right. It's times 1/3.
What's wrong with that one?
Top. Okay. Relax. Okay. Dividing by a whole number is the same thing as multiplying by what we call the number's reciprocal. You turn it upside down and you put a 1 on the top. Something new. And watch. I could prove this. Let's do this first. Give me a number to substitute in for R. T. Moses. Okay, good. You think small, which is good. All right, what's 6 divided by 3? T. 2. So it works for division. Let's see if we get 2 using this equation. Same thing, I'm going to substitute it in. 6 times 1/3. All right, now, do you know how to change a whole number into an improper fraction? You got to do that. Alexandra. Very good. And now we're going to multiply the numerators together. What's 6 times 1? What's 1 times 3? You get 6 over 3. It's called an improper fraction. Have you learned improper fractions? And then to turn it back into a mixed number, you take the bottom number. How many times does it go into the top number? And you get the same value. So that multiplying by 1/3 is the same as dividing by 3. Something new, but you're going to start to see it. All right, what about the unit rate? That's kind of new. What's the unit rate based on the value? Use the value to figure out unit rate. 1 what for every what? Because remember, unit means 1. Brando, 1 what for every what? You got it. 1 cup of, forgot the color. What was it? Blue. For every 3 cups of red. There's not a whole lot of room here. There's not a long line, so you got to write into the empty space. Right? Yeah. Oh, good so far? Yeah, finish that up. I'm curious to see how you set up your ratio table for this. I'll read it out loud to you. Mrs. Stein, or Ms. Stein, is a librarian who really enjoys reading. She can read 3/9 of a book in one day. 3/9 of a book in one day. I'm curious to see how you're going to float that in your ratio table. And this is what I want you to do. Do me a favor. I want to know what this first ratio is. Don't worry about scaling up just yet. Let's just worry about that first ratio based on the given ratio. All right? Don't try to scale it down yet, but what do you do with this piece of information right here? That's what I'm most curious about. All right, Alexandra. I called on you already, Alexandra. Let me go with Lucas Longo. What do you have? I just want this for now. What do you have? Come on up and do it, because it's just easier for you to do it rather than explain it. All right, step aside. How many of you would do it this way? Okay. Interesting. Does anybody have it differently? I'm not telling you whether you're right or wrong or not. We'll evaluate both. Okay, how many have it a different way? You have it different? Sit for a minute because I'm going to clone this page. I don't know if I can, yeah, I can clone it. Clone page. Okay, I'm going to erase this. Mikey Sims, come on. All right, this page is still here. It's just that I cloned it. Curious to see what you have. Where does he have you have it this way? You want to know who's right? You both are. They are actually equivalent ratios. Okay? They are actually equivalent ratios. The only difference is that in Mikey's version, he forced this 3/9 to 1 as a unit rate for days. Because this is very simply saying, in one day, this librarian can read how much book? In one day, she can read 3/9. She can't complete one book. She can only complete 3/9 in one day. That same librarian, in 9 days, it would take her 9 days to read 3 books. They are equivalent ratios. Okay. Now I know I'm going back and forth from page to page, but I can kind of show it to you visually. 3/9 to 1. What was the other ratio? No, it wasn't 1. What was the top? 3/9. Okay. Remember what our definition of an equivalent ratio is. Is that if I can multiply one quantity by a number, in this case times 9, 1 times 9 is 9, agree? Then if these are equivalent, 3/9 times 9 should be what? 3/9 times 9 should be what? Moose. Moose. What should it be? Moose. It should be 3. Let's see if it is. 3/9 times, what do I have to do to 9 to make it improper?
9/4.
Thank you. 3 times 9 is? 9 times 1 is? And guess what? 9 goes into 27 3 times. They are equivalent. Okay? So both ways are right. And then the other way you can do it, and I didn't put it on here, does anybody have 1 to 3? All you did is you just basically found the value of the ratio and you built. I'm going to use the 3 to 9 as our example. 6, what goes here?
18.
Then what?
9.
And
7.
finally,
18. 36. 12.
count by threes. Yep, count by threes. And
36.
good. All right, let's do our equations. First, what's our value of the ratio? Come on, guys, focus. What's our value of our ratio? Because we never know when we're going to need it. Chances are we're going to need it at some point, so we might as well just do it. Becca. Okay, 1 to 3. You already have it, right? So you're good. If you don't have it, put it over in the margin, 1 to 3. What's our multiplicative structure? Aiden? Absolutely, times 3. Okay, equation. D equals, days equals, what times what? Space. What? Okay, B times 3, how do we write it algebraically? What's the new way I showed you how to do it? Amanda? 3B. Very nice. B equals, and we could still leave the regular division symbol, but it would be B equals what? Joe? What do you got? D divided by what? By 3. Okay. Joe, take it one step further. That is the same as multiplying by what? Great. What about unit rate? Unit rate for books. One book for every what? Well, okay, ask me a question. Ask.
Do 3 over D instead of like D divided by 3.
If you're going to do division as what we call the fraction bar, if you're curious about it, it would be D divided by 3. You say it the way that you write it from top to bottom. What about unit rate? All right, Brando, one book. Close. Look at your value again. One book every, very nice, every 3 days. Okay, so now let's do the equation. How many books can Ms. Stein read in 27 days? Well, what are we solving for? Are they asking for us for days or for books? What do they want to know?
Days.
Look again, they give us days. Yeah, look for those keywords. How many, how much, how little. So we need the equation for B. B equals what? It's the theory of relativity. Come on, did I lose you? Look back, we've already created the equation. B equals what? Look over here, we already have it. Nick.
B equals D times 1.
Okay. I'm going to keep it simple though, Nick. Let's use division for now. It's just easier. Okay, what do we substitute in for D? Somebody I haven't heard from. Kai, I haven't heard from you, buddy. What do you substitute in for D here? What are they giving you? How much? Very nice. Okay, so we're going to do B equals 27 divided by 3. And what do you get? What do you get? 8. 9 books in 27 days. Okay? This we already did. That's the clone page. Okay, I want to get through one more page with you, and then I'll be able to announce your homework. I do need you to focus on this. It's not as difficult as it looks, but you got to pay attention. Once I tell you what to do, it'll make sense. Okay, here's what I want you to do first. Look at just this first coordinate plane on the far left and forget about everything else. Just look at the coordinate plane. According to the coordinate plane, in 1 hour, the car will have traveled how many miles? Chris? Come on, you can do this. Look at your coordinate plane on the far left. According to the coordinate plane, in 1 hour, how many miles has the car traveled? You got it. 60. What about after 2 hours? Amanda Rabich. 130. What about 3 hours? Becca. If you can't read it, think about it this way. You're counting by 65s. Anybody help her out with that? It's this number she's trying to read. What is it? 195. 4 hours. Ryan. 260. Finally, 5 hours. Alexandra. 325. Okay, now here's what we're going to do. On your right side, let me go to full screen on this. On your right side, you'll see we have 3 equations and we have 3 ratio tables. Let's do the ratio table first. Which ratio table matches up with that coordinate plane? Look at it. You have to look at your ratios, because one of these ratio tables will fit that coordinate plane and that coordinate plane only. Which one is it? Lucas, what do you think? Why do you say the first one? Where were you able to tell? Oh, so you used that value and said, oh, that's a match because at 2, I have 130. And you're right. So that's the letter B. And then you can cross it out because that one will not fit any other one. Now you ready? One of the equations, A, C, or E, will also fit that coordinate plane. And here's my hint. Usually, if you could figure out the value of each coordinate plane, it will help you to see the equation. Actually, I take that back. I'll take it a step further. If you could find the unit rate for each coordinate plane, you'll find the equation. All right, Moose, what? Either A, C, or E. What say you? How many think it's E? How did you know? Because you're right. You got it. There's 1 hour. It tells me 65. Look, guys, it's 65 miles per hour. This equation is 65 miles per hour. So now that's done. What about the second coordinate plane? Let's do the ratio table first. You have 2 choices. It's either going to be D or F, because E is already out, or B is already out. One of these, D or F, matches that up. It's a little bit trickier, because you'll see there's some in-between values here. Aiden, what do you think? How many think it's F? How'd you know? I lost you, bud. I will tell you, you're right. I just don't know if I understand your rationale there. Well, pick a value. 3 and 135. Okay, let's look. Here's 3. Trace it up. And you'll notice it's halfway between 120 and 150, isn't it? Well, what's halfway, number-wise, what's halfway between 120 and 150? Tyler, it's 135. So he is right. So that's going to match up with F. Cross it out. That's done. All right, what equation does that match? Again, use the strategy that Giuseppe told us. Look at the unit rate for 1, see where it matches up, and that will help you to determine what the equation is. Paul, what do you think? Letter what? We're doing equations, but it's either going to be C or A because we've already used E. How many think C? Very good, because look, at 1 hour you get halfway between 30 and 40. It's a little tiny up here, so you might have to look on your own sheet, but halfway between 30 and 60 is 45. So C is good. All right, now you can use elimination and whatever's left should fit, but let's just confirm it. Ratio table for the last one. All right, Will. All right, what values did you use to match up?
5 and 2.
Okay, so we take 5, trace it up. It's a perfect match because it lands on the line. 275 is good, so D is good. And then we're in good shape because you get a nice even number at 1 hour. Back. Correct, 55 miles an hour. All right, open up your agendas. I'll tell you what your homework is. You got to do the next 2 pages, 5 and 6. That's it. Okay? 5 and 6. So, Lucas, go on the blog tonight. See if it makes sense.